Okay, section 1.4. This is the section we need to cover this week for remote learning. So you should be able to watch this video and follow along just like we would a lecture in class. So I've got notes and examples that we work along the way. So in section 1.4, we're going to continue what we did with some of the work earlier in the week with linear equations, and we're going to look at quadratic equations. So quadratic equations are terms that have a quadratic or an x squared term. So if you remember something like bx plus c, this is a linear expression because my x is raised to the first power. When I see something like ax squared plus bx plus c, this is a quadratic expression because I have something raised to the second power. Okay, so we'll talk about some of the methods for solving. Main methods: completing the square quadratic formula, and then solving some explicit variable expressions that involve quadratics. So a quadratic equation can be written as ax squared plus bx plus c equals 0. So a and b and c are real numbers, and a is not equal to 0. If a was equal to 0, this term would go away, and you would have a linear expression. So that's why we have the explicit condition that a has to be not equal to 0. So this is a quadratic equation in standard form. So standard form of a quadratic equation is ax squared plus bx plus c equals 0. The fact that we see an equal sign tells me this is an equation, and I need to be able to solve this for the variable. So when we look at something like this, our goal will be to solve for the variable, which is x. And we'll talk about different methods that we can use to make this happen. Now we will also talk about the degree of equations. Later in the class, we're going to talk about polynomials and what their degrees are. We will also say here, so a quadratic equation is a second degree equation because the highest exponent that you see is the exponent of 2. So in this case, you look at it, this is a quadratic equation. So if I write it x squared minus 25 equals 0, and I'm trying to get it in the form ax squared plus bx plus c equals 0, here I know that a is equal to 1, b is equal to 0, and c is equal to negative 25. The next one, it is a second degree, is a quadratic equation. A is equal to 4, b is equal to 4, c is equal to negative 5. And the next one you see here, get it in standard form, ax squared plus bx plus c equals 0. So that's 3x squared minus 4x plus 8 equals 0. In this case, a is equal to 3, b is equal to negative 4, c is equal to 8. Okay, so looking at any equation with the degree exponent highest degree of 2 is a quadratic equation. Now, something we're going to rely on to solve quadratic equations is something called the zero factor property. It tells us if a and b are complex numbers and you multiply them to get 0, then one or both of those numbers has to be 0. So if you think about it, you've got this number, you got two numbers multiplied to give you 0. What is the only number you can multiply something by and get a 0? That is 0. So the only way this is true, this is a true statement, if a is equal to 0 or b is equal to 0. So if one or both of them is equal to 0, I'm guaranteed when I multiply them, I will get a 0. So for example, what if I had something like this? X minus 2 times x plus 3 is equal to 0. So what you see here, I've got this number and this number. I've got two numbers multiplied to give me 0. That means one of those numbers has to be 0. So either x minus 2 is equal to 0 or x plus 3 is equal to 0. If x minus 2 is equal to 0, That means x has to equal 2. And this means that x has to equal -3. So my solution to this equation is x is equal to 2 or -3. Those are the two solutions. So it's a little bit different than a linear. So a linear, you expect to solve for x and get one number. Quadratics, you've got different possibilities of what could happen. So in this case, I ended up with a quadratic, and I ended up with two solutions, x equal 2 and -3. So let's solve using the zero factor property. This requires, like many things in this class, you being able to factor. Okay, to solve, 6x squared plus 7x equal 3. So the first thing you want to do when you're solving these equations are to set them equal to 0. Makes your life much easier. So, and that's just the way we put it in standard form. Remember, standard form was ax squared plus bx plus c equals 0. So this is going to be 6x squared plus 7x minus 3 equals 0. Okay, this is a quadratic trinomial. So in order to solve this, I'm going to need to find a couple of things. I need to find two numbers that when I multiply those numbers, I get, what is 6 times -3? That's -18. So two numbers that multiply to give me a -18. And when I add those numbers, I get a +7. So what numbers can multiply to -18 and add to give me a 7? It looks like a 9 and a 2. If the 9 is positive and the 2 is negative, those numbers add to 7. Those numbers multiply to -18. So I need to rewrite this equation as 6x squared plus 9x minus 2x minus 3 equals 0. Now I can factor this by grouping. So look at the first two terms. What do they have in common? It looks like they have in common a 3x. What do I multiply 3x by to get 6x squared? That is 2x. What do I multiply 3x by to get 9x? That is plus 3. Okay, so I factored the first two terms. Bring down this sign that you see right here, a minus, okay? And now I group these together. So minus, if I write a 2x, that gives me minus 2x. Minus what gives me minus 3? There's going to be a plus 3 here. All I did was factor out the negative sign, or the -1. So you see negative times 2x is -2x. Negative times 3 is -3. Okay. Now you look at it and see there's a 2x plus 3 in common. So this is 3x minus 1, 2x plus 3 equals 0. I've got two things multiplied to give me 0. That means one of those has to be 0. Now I set each factor equal to 0. So if 3x minus 1 equals 0, or 2x plus 3 equals 0, this means that 3x equal 1, x equal 1/3, or 2x equal -3, x equal -3/2. Those are the two solutions, 1/3 and -3/2. So two solutions to this quadratic equation. Now there are some special forms of quadratic equations when you do not have a linear term. So when you're solving something like, ax squared plus c equals 0. When b is equal to 0 and there's no linear term, you can take the square root of both sides, okay? So a couple of things we can do here. Let's just look at it like, let's just say, for example, I'm not going to work through the example you have here. Let's look at something like x squared minus 25 equals 0, okay? I can isolate this squared term, so x squared is equal to 25. Now I can take the square root of both sides. the square root of x squared equal the square root of 25. Now when I take the square root of x squared, that just gives me x. But anytime I take the even root of an even power, I'm going to have two answers. What two numbers can you square to get 25? Well, that's a 5 and a negative 5. There are going to be two answers here. So the square root of x squared, I have to take care of it like this, is plus or minus the square root of 25. So x is plus or minus 5. So you have to keep in mind that you will have a plus or minus in your answer anytime you have an even root and you're taking an even root of an even exponent. So something like x squared equal 25. What if I had something like 3x squared equal 48? Well, what I really want to do, I want to isolate this x squared term so I can divide both sides by 3 and I get x squared equals 16. And then I'm going to take the square root of both sides, x equal plus or minus 4. Okay. And this is just telling you what you know here. If you have x squared equal k, when you take the square root of both sides, just remember when you take the square root of an exponent that's squared, you're going to get x equal, and you have to have this plus or minus over here. So x is plus or minus the square root of k. Okay, let's solve a few equations here. X squared equals 17. Okay, I've got the exponent isolated, so I'm going to take the square root of both sides. Square root of x squared is x, and then I have plus or minus the square root of 17. Okay, just keep in mind the knowledge that you're bringing to this is anytime you get to this situation, square root of x squared, your answer will contain a plus or minus. Okay, so plus or minus root 17 is the answer there. Solving this equation, x squared equal negative 25. So in this case, so I've got x squared equal negative 25. I take the square root of both sides. So I get x equal plus or minus the square root of negative 25. Well, the other way of thinking about this is x equal plus or minus. This is negative 1 times 25. By definition, what is the square root of negative 1? That's I. So x is equal to plus or minus I, the square root of 25. What is the square root of 25? That's 5. So x is equal to plus or minus 5i. So the only difference here is you were taking the square root of a negative number, which is going to give you a complex number. Remembering square root of negative 1 is always I. Now let's do this one a little bit different. X minus 4 squared is equal to 12. So same concept. X minus 4 squared is equal to 12. The key to solving this, since it's squared, that term is isolated, I'm going to take the square root of both sides. So when I take the square root of the left, I get x minus 4 equal. I'm going to have a plus or minus in my answer, and this is the square root of 12. To solve this for x, you can just add a 4 to both sides. So x is equal to 4 plus or minus the square root of 12. Now you can simplify square root of 12 a little bit differently. It's x equal 4 plus or minus. 12 can be written as 4 times 3. So what is the square root of 4? That's 2. So x is equal to 4 plus or minus 2 square root of 3. That is the simplest form of this. So I would probably, on a test, I would probably take both of those as answers. Okay. So the key here was isolating this term that is squared. And remember, anytime you take the square root of something squared, you're going to have a plus or minus in your answer. What if we had something like 3x minus 1 squared is equal to 12? Well, first thing I'd want to do, I want to isolate whatever is being squared. Let's divide everything by 3, and I get x minus 1 squared equal 4. Now I take the square root of both sides, so I get x minus 1 equal plus or minus the square root of 4. So bringing this down here, x minus 1 equal plus or minus the square root of 4 is 2. So x equal 1 plus or minus 2. What's 1 plus 2? That's 3. What's 1 minus 2? That's negative 1. So your answers there are 3 and negative 1. Now we have another method for, we've got two more that we need to do here, but another method we have for solving quadratics is something called completing the square. So when you've got something that can't be factored, we have ways of manipulating it so that it can be factored as a perfect square, and then you can solve using square roots. So let's talk about the way this is done. Let's just use an example here. So x squared minus 4x minus 14. So if I tried to factor this, okay, so x squared minus 4x minus 14 equals 0. If this can be factored, I would need to find two numbers that multiply to negative 14 and add to negative 4. What are the factors of 14? 1 and 14 and 2 and 7. There is no way I can multiply those numbers and get a negative 14 and then combine them to get a negative 4. This cannot be factored. So what I can do something like this. So x squared minus 4x, let's move that 14 to the other side. Okay. And now I want to figure out what is it that I can do that makes this left side of the term factorable. So here's the process. What I need to do is, this number right here you have is a negative 4. So you take half of that coefficient 4 and you square it. And you're going to add to both sides. And you'll see why this works in just a moment. So I'm going to write this as x squared minus 4x. What is half of 4? That's 2. Okay? So I'm going to add 2 squared. Okay? If I add 2 squared to the left side of the equation, what do I have to add to the right side of the equation? I got to add the same thing. So if you look at from this step to this step, these are the same equations. All I did was add 2 squared, or 4, to both sides of the equation. Okay? Now, the left side should factor. So if you look at the left side, if I look at this, are there two numbers that multiply to 4 and add to give you negative 4? It looks like negative 2 and negative 2 will do that. You multiply to get 4, you add to get negative 4. So this can factor as x minus 2 equal, and what is the right side? That's 14 plus 4, that is 18. Okay. Well, x minus 2 times x minus 2, that is x minus 2 squared equal 18. So this is why it's called completing the square. If you look at this coefficient and you take half of it and you square it and you add it to the trinomial, you're guaranteed to get something that factors as a perfect square. So now, in order to solve this, you take the square root of both sides. X minus 2 equal plus or minus the square root of 18. X equal 2 plus or minus the square root of 18. And we can simplify that a little bit more. This is x equal 2 plus or minus the square root of 9 times 2. X equal 2 plus or minus the square root of 9 is 3. So 2 plus or minus 3 square root of 2. Okay. So again, the key here when you're completing the square is whatever this coefficient is, you're going to take half of that and square it. Add that to both sides of the equation. That guarantees you're going to be able to factor one side of the equation as a perfect square. Let's do another example of that. Let me see, I've got a little bit of space here. Let's just do one here. Let's just say that we had x squared plus, let's say, 6x minus 1 equals 0. So the method for completing the square is to x squared plus 6x, move the constant over to the other side, and now I need to add, what is half of 6? I need to add that squared, okay? So that is adding 9 to the left side of the equation. If I'm going to add 9 to the left side of the equation, I also have to add 9 to the right side of the equation, okay? And then what this becomes x plus 3 squared equal 10. The way you get that, if you look at this left side, that's x squared plus 6x plus 9. What numbers multiply to 9 and add to 6? So the two numbers that multiply to 9 and add to 6 are 3 and 3. So this is x plus 3, x plus 3. So the reason I write this is instead of just adding a 9, I wrote add 3 squared, because when you come to factor this, it's going to be x, whatever this is, plus this. So it's x plus 3 squared equal 10. Take the square root of both sides. X plus 3 equal plus or minus the square root of 10. X equal negative 3 plus or minus the square root of 10. Those are your two solutions to that equation. Now, where it gets a little bit more involved is when you have something like this. 9x squared minus 12x plus 9 equals 0. So what we have here is the term in front of the x squared is not a 1. The previous two examples started with x squared. What you have to be able to do here is you've got to be able to get the x squared in terms of a coefficient of being 1, okay? So what I need to do here is divide everything by 9. So if I divide everything by 9, then I'm going to end up with this equation right over here. X squared minus 12/9 x plus 1 equals 0. And now I just solve it like I did a moment ago. X squared, 12/9, those are all divisible by 3. So that's minus 4/3 x, and then move that 1 to the other side. Now I need to complete the square. So I need to figure out what is 1/2 of 4/3, and then I need to square that. That's what needs to be added to both sides. So what is 1/2 times 4/3? Okay, so 1/2 times 4/3 is what? So 1/2 times 4/3 is 4/6, or 2/3. Okay, so I need to add 2/3 squared to both sides. So x squared minus 4/3 x plus 2/3 squared equal negative 1 plus 2/3 squared. Now the reason we do this is the left side simplifies. This is x, take this sign right here, minus, take this number. This is x minus 2/3 squared. equal -1 plus, what is 2/3 squared? 2/3 squared is 4/9. 2/3 times 2/3 is 4/9. So x minus 2/3 squared is equal to, I'm going to rewrite 1 as -9/9. So what's -9/9? That's -1. -9/9 plus 4/9, that's -5/9. So x minus 2/3 squared equal -5/9. Now I take the square root of both sides. X minus 2/3 equal plus or minus square root of -5/9. So x minus 2/3 equal plus or minus. That negative is just going to become I, and then you're going to have the square root of 5 over the square root of 9, which is just 3. Okay. So your final answer here is x equal 2/3 plus or minus I times the square root of 5 over 3. Okay. So a little bit complicated, but anytime you have a number other than 1 in front of your quadratic, you've got to divide by that number, factor that number out so that you can use completing the square. And that's the one that we just did. Okay. Which brings us to what we're leading up to here is the quadratic formula. So what we've done so far, we've solved quadratics by taking the square root of both sides. And then we will also solve by completing the square, which you just saw. And then the last time we're going to solve it, or the last method, is quadratic formula. So if we start with this equation, ax squared plus bx plus c is equal to 0. We have a formula that will always work for solving this. You may have learned this in previous math classes. It's called the quadratic formula. X equal -b plus or minus the square root of b squared minus 4ac. All of that is divided by 2a. So this is a formula you will need to know. What I tell people is when you look at the left side of this equation, that's the algebra. When you look at the right side of the equation, that's arithmetic. The harder thing about the quadratic formula, it's not the algebra, it's the arithmetic that you have to keep straight. So we'll do a few examples of solving using the quadratic formula. And here you have it written just like I did the quadratic formula. And one of the common mistakes people make is when they write this 2a, sometimes they'll just let it go right underneath the radical. But this 2a is the denominator for everything. So it's a one big fraction bar that you see there. Now what I'm going to do when I solve these, I'm going to take an extra step that just breaks it down. So to solve something like this, so when I look at something like this, if I need to solve it, solving is much easier in most cases when something is set equal to 0. So x squared minus 4x plus 2 equals 0. Okay, that is now set equal to 0. Now, this is in standard form. This is ax squared plus bx plus c equal to 0. In my case, the coefficient of x squared is 1, b is equal to -4, c is equal to 2. So I want to use the quadratic formula, which is x equal -b plus or minus square root of b squared minus 4ac, all of that over 2a. Now, I find it easy to break this in two steps. First of all, let's find what is b squared minus 4ac. Let's do that part first. b squared minus 4ac, that is negative 4 squared minus 4a, and c is 2. So this is negative 4 squared. This is 16 minus 8, which is equal to 8. Okay, so I know that b squared minus 4ac is equal to 8. Now I'm just going to go use this formula right here. So substituting everything in, I get x equal, what is negative b? Negative b is going to be 4. Plus or minus the square root of b squared minus 4ac. We just determined that b squared minus 4ac is 8. All of this divided by 2 times a, and in my case, a is equal to 1. So simplifying this further, I get x equal 4 plus or minus, I'm going to write 8 as what, 2 times 4? All of this over 2. And so what is the square root of 4? That's 2. So I get x equal 4 plus or minus 2, square root of 2. All of that over 2. And this would be an okay answer. It can be a little bit simpler if I look at it like this. What is 4 divided by 2? That's 2. So this is x equal 2 plus or minus 2 divided by 2 is 1. This simplifies to 2 plus or minus square root of 2. So I would probably take both of these as an answer in this case. And that's where we are. Yeah, 2 plus or minus the square root of 2 is the lowest term answer. Let's look at another example. So they've got another example for us here using the quadratic formula. And first step, get it in standard form. So 2x squared minus x plus 4 equals 0. Remember standard form, a x squared plus bx plus c equals 0. In this problem, a is equal to 2, b is equal to negative 1, c is equal to 4. Okay. So when I do quadratic formula, I like to break it up. Let's figure out b squared minus 4ac first. So that's going to be negative 1 squared minus 4ac. So this is going to be 1 minus 32. 1 minus 32 is negative 31. So b squared minus 4ac is negative 31. So now let's go forward and use a quadratic formula. X equal, so remember our formula, negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x equal, negative b is 1 plus or minus the square root of, what is b squared minus 4ac? We just determined that's negative 31. All of that over 2a, a is equal to 2. So this is x equal 1 plus or minus the square root of negative 31, that's going to be I times the square root of 31 over 4. So that's your answer, x equal 1 plus or minus I times the square root of 31, all of that divided by 4. And that's it. Now we got a couple examples of solving for variables when I have something with a quadratic in the formula. So this is the formula, an area formula. So what if I needed to solve this for D? Okay, so if I look at how would I solve this equation for D? Well, to solve for D means I want to get the D isolated by itself. Okay, so in order to do that, I've got A is equal to pi d squared over 4. So in order to get everything by itself, the first thing I could do would be, let's multiply everything in this equation by 4. And you get 4a is equal to pi d squared. Now in order to get the d by itself, I could divide everything by pi. So I get 4a over pi equal d squared. Now to take square root of both sides, that's going to give me d is equal to, remember when I take this, I'm going to have plus or minus the square root of 4a over pi. So I've got two answers for that. D is equal to plus or minus the square root of 4a over pi. And I think they simplified just a little bit further. That would be okay. All they did here was, what's the square root of 4? That's 2. So I could write this as plus or minus 2 square root of a over pi is equal to d. But either of these answers would be fine. Okay? So again, the key here is with the quadratic formula being very picky and neat and exact about your arithmetic with a quadratic formula. Let's just do another example as we end up here. Let's say 2x squared plus x minus 1 equals 0. So to use the quadratic formula, that is a, x squared plus bx plus c equals 0. In this case, a is equal to 2, b is equal to 1, c is equal to negative 1. So what is b squared minus 4ac? In this case, that's 1 squared minus 4 times 2 times negative 1. That is 1 plus 8, which is equal to 9. So now if I go to my formula, x equal negative b plus or minus square root of b squared minus 4ac, all of that over 2a. So now it's just plugging everything in. What is negative b? Negative b is going to be negative 1 plus or minus the square root of, what is b squared minus 4ac? We've already determined that's 9 over 2a. What is a in this case? That's 2. So this is x equal negative 1 plus or minus, what's the square root of 9? That's 3. All of this over 4. So your answers are x equal, what is negative 1 plus 3? That's going to be 2, so you get 2. So you'll get 2/4. What's negative 1 minus 3? That's negative 4. So 2/4 or negative 4/4. So your answers are going to be 1/2 or negative 1. Okay, that should be it for the lecture part of 1.4.